All right, in today's video, we're going to be looking at something called definite integrals. Now, we've talked about indefinite integrals, which is like just the general form of an integral, but now we want to start substituting values in for x. Now, why would we want to do that? Let's say we take some function, and we can kind of look at this little graph here. I have some line, and our job is to try to figure out the area under this line. And we want to find the area from A to B. Now, if we had something like this shape, we could probably use just some geometric properties. This looks like kind of like a trapezoid. But if I took a function that was curved and I needed to do the same thing, find this area, right, now I'm kind of stuck because this is not as easy to do. What the definite integral allows us to do, and we're going to do a little activity on Gizmo so you can kind of play around with this in class, is that definite integrals, the process of it is basically calculating the area by filling that space with like an infinite number of small rectangles, calculating the area of each rectangle, and then adding them all up, right? Instead of doing all of that, because that takes a long time, we can just do the definite integral. Now, what the definite integral is this function right here. It's the integral from b to a of f of x dx, where a is the lower x value and b is the larger x value. So we call it the lower limit and the upper limit for integration. Right? As long as this is a positive function, we can sub these values in for b and a and solve for our answer. We take the indefinite integral or the antiderivative, then we sub in the x values. If we sub in the x values right off the bat, there's going to be nothing really to integrate, which kind of then beats the purpose. So let's look at some questions here and how this would work. All right, these are just the general rules, which you can kind of look over in detail. If I'm taking an integral and I have a constant term k, we're allowed to move this constant to the outside so we can just take the integral of the original function and then multiply by k at the end. Right? If we have the definite integral of two functions adding each other, we can take the integral of the first function plus or minus the integral of the second function, right? We can separate them so we can do one thing at a time, just like we would do with derivatives. If we have to do from A to A, right? If the area between 2 points, well, if the point is the same, then it's just a line. There is no space between them. Therefore, that integral would have to be equal to 0. Right? If we want to change our bounds, right? If we're going from B to A, but we want it to be the other way around to make it from A to B, all we need to do is add a negative in front of our integration sign and switch our bounds. And the last rule that we're going to talk about is that the integral from A to B, okay, and let's kind of talk, if I have a graph here where I have A to B, let's just say this is C. Sometimes we have functions where we don't have everything. If I want to get the integral from A to B, you can take the integral from A to C, which would be this space, and then add it from B to C, which would be this space, and that gives us the entire space. All right, those are our 5 properties that you're going to have to learn. Let's apply them to some questions. So here we have the integral from 4 to 2 of some function is equal to 7. The integral from 3 to 2 of some function, g of x, is equal to 3. And again, the integral from some function, g of x, from 4 to 3 is negative 4. Then we want to evaluate these 4 properties. So we're going to be kind of using all the rules that we just talked about in our equations. Let's see how this works. Now, in our first question, if I'm looking at all these, I don't have the integral from 2 to 4. But I have the integral from 2 to 3, and then the integral from 3 to 4. So I can rewrite this, or basically integral, as the integral of 3 to g of x. 3 is the upper limit, 2 is the bottom limit, dx. Then add the integral from 4 to 3 of g of x dx. And I have values that I can substitute in both of these functions. So in this case, from 2 to 3, right, that's equal to 3. From 3 to 4 is negative 4. Therefore, this would be our negative 1 answer. Let's look at the second one. We're evaluating some definite integral from basically 4 to 2 of 4f of x minus 2g of x dx. Again, if I only have these properties given, right? I can't actually take the integral of anything because I don't know what f of x and g of x is. So I just have to use these three properties. Now, if I'm looking at f of x, I can kind of rewrite this as 4 times the integral of f of x from 4 to 2 minus 2 times the integral of g of x. Yeah, dx dx. Now that I kind of have it into two separate problems, right, I have the answer of f of x dx from like 2 to 4 or 4 to 2, however you want to say it. Well, that would be, right, this whole piece is equal to 7. So that's 4 times 7 minus 2 times the integral of g of x, and that integral was asked to go from also from 4 to 2. Now, that's not coming from our properties, but look right here. We just got that answer. It's -1, so I can just plug that answer right here. -2 times -1 is +2. 4 times 7 is 28. We add those together, we get 30. Let's keep it moving here. C. Now we have from 2 to 2, f of x dx plus 2 to 4 of g of x. Again, all we're doing really is applying all these properties that we're learning and learning how we can kind of manipulate our integrals before we jump into real functions in the next lesson. Right off the bat, I noticed that if these numbers are the same, this integral is equal to 0. So really this question is just asking, well, what's the integral from 2, 4 of g of x dx? Well, we don't have that answer, but we have the answer from 4 to 2. So we're going to apply that negative rule that we learned. But if I want to change the bounds the other way around and do this, I have to have a negative out front. And now I can take this integral. Since the integral of g of x from 2 to 4 or 4 to 2, right, is right here, is -1, our answer would then have to be negative times -1, which would be +1. All right. Last one here, we have another integral from 2 to 0 of 3 over 2 times f of x plus 2. Now, this is kind of weird because we're adding 2 to our x values. We're kind of shifting our function right to. Now, I can't do this because I don't have 0 and 2 in my function. But what we're allowed to do is I can take this plus 2 and I can just move the bounds 2 over. So this is the same thing as writing our function from 4 to 2 of 3 over 2 of f of x dx. That's equal to 3 over 2. All right, if I just kind of factor out the constant. And now I know the integral of f of x from 2 to 4 or 4 to 2. That's right out of our kind of worksheet here is 7. So this would be 3 over 2 times 7, which would give us an answer of 21 over 2. Okay, so those are 4 questions that just to practice using our integral properties. We will do this with real antiderivatives in the next lesson, but you need to make sure you know how all of these properties are going to work. All right, so here are the questions that you're going to be doing in class. And again, if you have any questions, please make sure to let us know.